Good afternoon, ladies and gentlemen. My name is Ross Bradson. I'm the Regional Director for OCE for Southwestern Ontario, and I'm also the Sector Lead for Advanced Manufacturing, which is where our mining initiatives fall as well. Hard rock mining in Canada entails formidable challenges, but overcoming them through innovation would produce high-grade rewards. The challenges involve issues like the high cost and availability of energy, geotechnical risk and stability, materials handling, and productivity levels in underground mines. These are only exacerbated by remote locations far away from established power and transportation infrastructure, and excavation depths in excess of 2 kilometers deep make this very difficult. This panel will explore the potential for innovative solutions in Ontario, which could open up global markets at a time when demand for metals worldwide continues to escalate. I would like to introduce the moderator for this panel, Douglas Morrison, President and CEO for the Centre for Excellence in Mining Innovation. Douglas has 14 years of operating experience in deep nickel mines in the Sudbury Basin, where he became the Superintendent of Rock Mechanics and Mine Design at Inco, now Vale. He has since spent 15 years as a consultant at Golder Associates. Is that an important announcement? I'll just keep going. He has since spent 15 years as a consultant at Golder Associates, working on strategic design, productivity, and safety issues in mines around the world. Douglas has held progressively senior and key roles at CEMI, and last year he was appointed the President and CEO of CEMI. Thank you very much for joining us, Douglas. Over to you.
Okay. Thank you very much, Ross. Although that might sound like a boring list of technical topics to be talking about, this is one of the most sexy businesses to be in. And everybody else in the rest of the hall depends entirely on the products that we produce. None of that happens unless we do our business and do it very, very well into the future. And that's what we're going to be talking about today. So I'm delighted to welcome 4 panelists: Dick DeStefano, who's the President and CEO of the SAMHSA Group, which is the services and supply sector in Sudbury, Northern Ontario. Then we have Dr. Dean Millar, who's the Professor of Energy, Renewables and Carbon Management at Laurentian University, working at MIRARCO. He's taught at Imperial College, Exeter's Camborne School of Mines and the University of Delft. And his interest is in energy issues in the underground mining business. Then we have Dr. Daniel Campbell, also at Laurentian University, who's focused on environmental impacts and reclamation of mine sites, which is critically important to the particularly sensitive environments in the very far north. And then finally, we have Richard Fink, who is the Vice President of Technology for Cliffs Natural Resources, and who is one of the people directly involved in the development of the mineral deposits in the far north of Ontario, in a place called the Ring of Fire. We prefer to call it McFalls Lake area of the province, but it's very, very remote and exemplifies some of the very serious challenges that we have for remote areas and accelerating mining developments in these remote areas. Our other colleagues here, and the things I will talk about, are all about how to sustain mining in existing mining communities where mines already exist, and where we have to go deeper to extract the necessary resources to meet everyone's needs that are served by the global industrial complex. So, my distinguished panel, here they are. I'm going to give an introduction first, Dick.
Do you want me to stand up?
No, I'm going to talk first.
Okay.
I'm doing an introduction, and then you're going to start.
Am I?
Yes. Okay. So, when it comes to them actually making their individual presentations, we'll hold all the questions to the end. Some of them will overlap, and that will actually help the integration of the whole conversation. I think here we're moving on to CEMI's objective is to be the leading source of innovation for the global mining industry. Not just Northern Ontario, not just Canada, for the world. All of the issues that we have to deal with in Ontario are the issues that have to be dealt with everywhere else, and that's our objective. We're actually confronted with 5 different strategic themes: exploration, deep mining, which I'll show you some pictures of, problems of rock stress and heat stress, integrated mine operations, changing the way we do our business, underground mine construction, speeding up the rate at which we access underground ore deposits, and finally, environmental impact, and how we manage the environment and help communities manage their local community. The advantage that Northern Ontario has is the living laboratories. We have 15 to 20 mines at any one time in the far north, all of which represent opportunities for living laboratories to try out new techniques and new ways of doing things. And all of these issues are things that we're working with in these mines. Then we have very large tailings and waste management facilities. All metal mines produce a level of grade which is less than 5%, which means that 95% of the material produced by an underground metal mine is waste. So management of waste and wastewater is one of the most important things that we do, and we have to do very well. And we have so many facilities in the far north, we experiment there also with different ways of making that happen. And finally, the geology. There are many, many more resources to be discovered in the northern parts of Ontario, and how we do that helps everyone on the planet find more resources. Here we are. One of our challenges in Sudbury is to attract the attention of everybody else living in the south. In southern Ontario, we have a high concentration of universities and intellectual capital, and we need to attract that intellectual capital to our problems in the far north. Everybody here, of course, from southern Ontario thinks that Sudbury is in the far north. Actually, we're not in the north at all. The north is much, much further away than that. And we'll come back to that in a while. So one of our objectives is to attract the academics that we have working in these environments to come and help solve our problems, and thereby help us meet everyone's needs. We're not just focused in Northern Ontario and in Sudbury, but we have projects all around the world, and we have collaborators all around the world. We have 3 major projects in Australia, 1 major project in Chile, and other collaborators in North America and in Europe. So we are based in Sudbury, but we attract a network of collaborators to work on the issues that have to be addressed by the global mining industry. Not the Canadian mining industry, although we are in the forefront of most of these developments, but the global mining industry. This is our source of funding. We started off 6 years ago now with $18 million. We managed to leverage that with another $22 million to make $40 million. And we've expended most of that already on various programs and deliverables. And so the match that we work with is essentially a close to 1-to-1 match. Sometimes it's more, sometimes it's less, but over the 6-year period we've been operating, the match has been roughly 1-to-1. This is what we try to do. People say, why do we need an organization like CEMI to exist at all? We exist because the industry has to have us there. Industry is now primarily focused on production, productivity, and health and safety of its workforce. That's their primary task. There were many years ago, I worked at some of the large mining companies, and at that time they had internal resources to devote to things like innovation and research, and they no longer do. We have very thin operations, and they have to be focused on production. Then we have the universities, and they do very good research, but research is not innovation. CEMI is the Center for Excellence in Mining Innovation, not mining research. That means getting things implemented into mine operations. Not just conducting a research project that then sits on a shelf, but actually taking that through the commercialization process so that it actually becomes part of future operations for all the mines. And finally, one of the most important things that people that we have to work with is the service and supply sector. The service and supply sector are the people who actually get things done in mines and supply goods and services to the operations. If we want to commercialize a research product, those people in the SMEs are the most likely people to help us do that. In fact, many academics, not my colleagues here, but many academics are academics because they don't actually want to have anything to do with industry. They went to the universities to avoid industrial involvement. The colleagues we have here are not like that at all, but if we want to get something implemented, the SME community is where we will find our most willing partners to make that happen. And so what we intend to do at CEMI is to develop step change innovations, significant changes in the way mining practice is executed. We also work with several other organizations. There are several research groups that we work with. MIRARCO, MDRU, CanMet, NORCAT, Camiro, all of those are organizations that we've collaborated with in the past and will again in the future in order to make these things happen, along with individual companies and individual researchers in different parts of the world. There are other organizations like CEMI that exist, and they are there to help us as well. But we focus exclusively on underground metal mining. As I say, metal mine is specific because we mine relatively low grades, and it means we have a major issue to manage the waste products that we produce, and it's non-trivial. This is the way it used to be in the old days, and when I started 30 years ago, it wasn't significantly different from this. We do actually have color photography now in the mines, and this is the kind of equipment that we use. That's the scale. We scaled up very significantly and changed the equipment that we use from small handheld pneumatic equipment to very, very large trucks and front-end loaders. These mines are also very deep. Typically, the mines in the north are certainly deeper than 2 kilometers, if not 2.5 kilometers. 2.5 kilometers is roughly the equivalent of a high-rise building 700 stories high. And we have vehicles down there that are much larger than any truck and transport that you have on the highway. That's the scale of operations that are operating in Ontario every single day of the week. The issues that we have in these deep operations are the rock stresses that you can see. You can see one of the failures looks like it's just a normal collapse. In actual fact, the one to the top right in the middle is material that was ejected sideways, laterally from the rock face by a seismic event. These mines are so deep, they actually generate their own earthquakes. And that's one of the stability problems that we have. The other thing is, all the water that you see in the top right-hand corner, that's water that we bring down to the underground environment in order to operate the machines. There is no natural water there. At 2.5 kilometers below surface, we're a long way from the water table. It's completely dry, and one of our biggest issues is dust. Heat and dust. Typically, the air temperature in these mines is 35 to 40 degrees centigrade. So just as the whole of Ontario is closing down when the office temperature goes to 40 degrees centigrade, our employees are just going to work in those temperatures. As these mines get deeper, however, that becomes less and less feasible, and we need to adjust our operations to match. 3 types of innovation. Core innovation means slightly improving what we do. Continuous improvement, minor ongoing costs, better understanding of what we do, etc. Adjacent innovation means introducing technologies from other industries to help improve the performance of our own industry. And then finally, disruptive innovation, which means a transformational change. You can actually spend a lot of time and money in the right-hand box and actually not get a great deal. So we intend to focus most of our attention in the 2 left-hand boxes, not because we don't want to make big changes. We do. We want to make significant changes, and we think we can do it with spending most of our time in the left-hand box. However, we will have stretch projects that move into the disruptive zone, and we'll show you some of those before we finish the afternoon. The kinds and the scale of improvement that we want to see is double and triple the performance of what we have now, or half the cost, or 1/3 the cost of the same type of operation. That's the scale of change that our mines have to see in the future. The reason is very simple. For the last 60 or 70 years, the global mining industry has met the needs of 1 billion middle-class lifestyles, concentrated mostly in Western Europe and North America. And now we have another 2 billion people in India and China who would aspire to the same lifestyle with exactly the same resource demand. That lifestyle has the same resource demand, and it means we need to produce 3 times more material if everyone is to have all of their needs met. And we have to do that at a time when we've passed peak copper, peak nickel, peak lead, zinc, and chrome, etc. These resources, we have extracted all the easy materials. So at a time when we need to triple the output of the global industry to meet everyone's needs, we have to do it in more arduous and difficult and remote conditions. That's the challenge that confronts our industry. And we have to do it at a time when we need to make a complete change in the workforce that we have. In Canada, at least, the average age of our workforce is roughly 55, which means in 10 years' time, we need a whole new generation of people working in our operations with a much better understanding of how we have to function in these environments than we have at the present time. So, what we've discovered at the Centre for Excellence in Mining Innovation is it's not just about research and development. Research alone will not take us where we need to go. We also have to have things implemented into operations, and not just implemented as a one-off exercise. It has to become an integral part of future operations. And that means innovation actually means operational integration. That means taking care of the issues to do with the cost of the innovation, the IP, the way it functions, the way it affects the interaction with different people, the way it changes the incentive systems that we have in the mines to make it function and be adopted as the normal practice for the future. That means that we work very closely with the SME community, and Dick is going to talk about that in a few minutes. That's our Innovation and Prosperity Office, where we try to interact with the service and supply sector. Oftentimes that means bringing forward some ideas that they have for innovations, and there's some small technical glitch that they can't overcome, and we find them some researchers to solve their technical problems. So here we are at the Innovation Prosperity Office. The original idea was to focus on applied research and help them work there, and we'd work with Camiro and MIRARCO and Cambrian Boreal colleges, and with NORCAT as an incubator of a new business. If we solve some of the applied technology problems and take that business forward, it either becomes part of a service offering for an existing company, or it becomes a new company, and that new company will be incubated in the NORCAT Centre, which is situated close to Cambrian College. What we actually discovered when many of these entrepreneurs and SMEs came forward was the natural fact they don't have a small applied technical problem, they have a fundamental problem. And we tied them up with much more sophisticated researchers to look at the fundamental issues that are stopping their business from going forward. And finally, we actually discovered that many of these entrepreneurs had not taken care of the business aspects of their new innovation, so they had not secured patents, they had difficulties with other investors, and so we helped them with their legal and management consulting roles. These are the people that we integrate with. SAMHSA is the group that Dick will talk about. Laurentian University, 2 professors from here, NORCAT, Camiro, the colleges. The whole issue is focused on how do we make these innovations be adopted by the industry and not just left on the shelf. So we've spent about $20 million on over 40 strategic research projects, $2.5 million for research chairs to address some of the fundamental issues that we have to address. We've collaborated with over 30 professors and 60 co-op students. That means the co-op students are actually functioning in the mines. All of our research projects are actually involved in mines where the mining company is involved in funding the project as well as conducting the projects that we have in their mines. So we don't actually have a membership where you join, like joining the gym, go twice, and then don't participate any further. You're only involved in our projects if you're continuously committed to making those research projects move forward. Oh. Those are some of the things that we've supplied to the industry. Fugitive dust control, that's from tailings ponds. Pre-concentration assessment tool, that helps us to divert some of the waste and not hoist valueless material to surface. The geotechnical risks are the ones that are most critical to the safety of the operations, and that's true for the burstborne mines in particular. That's the solution team. So for our first 5 years, we focused largely on the middle box, which is all the geotechnical issues. That was the most pressing issue. We still have conditions that are difficult to manage, but we have that pretty well under control. The deeper we go, the more difficult it will become, so that problem will never go away for us. The top box is ventilation. Ventilation is becoming a completely critical issue. When I joined the industry 30 years ago, nobody wanted to be the vent guy in the mine because it was the most boring job of all. It is actually now one of the most critical jobs that we have because of the temperatures. It's extraordinarily difficult for us to keep these mines cool, and by cool I mean 35 to 40 degrees centigrade, without spending tens and hundreds of millions of dollars on additional ventilation. So ventilation is a serious issue for us. And then the rate at which we develop tunnels in our operations, Rio Tinto has adopted a view that they want to use tunnel boring machines and shaft boring machines that look like this. In the top left-hand corner, you can see the typical drilling and blasting machines that we use in the Sudbury Basin and all across North America. Rio Tinto wants to use the machines below that to cut their tunnels at a rate of 20 meters a day. In the top left, with our conventional methods, our advance rate is less than 4 meters per day. Very, very slow, and much slower than it used to be. In order for Rio Tinto to bring on its mines at the rate at which they need to meet the world demand for copper, they need to bring these mines on stream at 20 meters per day. And the machine on the right-hand side is a shaft boring system, which creates a shaft 11 meters in diameter, 2 kilometers deep, and these large mines, copper porphyry mines, will produce 150,000 tons per day. That's the scale that these shafts are designed to meet. The entire production from all of the mines in the Sudbury Basin, all 12 of the mines at the present time, is less than 50,000 tons for all of those mines. One single mine of a copper porphyry mine will produce 150,000 tons per day. It's an enormous logistical challenge. Our difficulty in Sudbury is that our rock is too hard for us to use these kinds of techniques. These techniques only work on mines where the rock is less than 150 megapascals. Our rock is 150 to 200 megapascals. And because the shape of our ore bodies is variable, we have to use multi-directional tunnels. These tunnel boring machines have a turning radius of about 30 meters, which means they don't do corners very effectively. So we can't cut the rock, and they don't do corners, so they don't work for us. That leaves us to use conventional drilling and blasting techniques, but we still have to improve our performance from 4 meters a day. 4 meters a day will not give us an acceptable result at depth. I'm going backwards. So move forwards. So we want to move from 4 meters a day to 8 meters a day and up to 12 meters a day by adjusting the sequence of activities that we have in these tunnels to significantly improve our performance. Again, 8 meters a day means doubling the rate, and 12 meters a day means tripling the rate of advance. That's what we have to achieve to maintain our productivity levels at the necessary level for these deep operations. That's how we propose to do it. If we bring in a canopy, as you can see on the right-hand side, it allows us then to do the ground support cycle, the drilling cycle, and the loading cycle simultaneously. At the present time, we do each one of those sequentially with individual pieces of equipment. So we want to reduce the numbers of pieces of equipment and have simultaneous activity in the tunnel at the same time. And the canopy will allow us to do this. That's what it looks like. It means our machines are protected by a temporary head cover, and it allows our people to work underneath it and run those operations. Next, we need to move to production, and we need to double and triple the production levels that we have. And that means by reducing the energy requirements, continuous draw point mucking, consuming the waste rock underground. At the present time, every ton of waste, which is valueless material, the rock that we mine out to make the tunnels to create the access, all of that material is hoisted to surface, no matter how far away the surface is. And so we actually have to stop doing that and consume that waste rock underground as much as possible. So one of the things we need to do is to develop a logistical loop to make it possible for us to do that. We need a top-down mining method to minimize the pre-production waste development. It has to be selective, and it avoids putting in more and more ground support. It means the backfill that we use, every void underground is actually filled with cemented tailings. And if we switch to tailings fill, tailings paste fill, we can double the rate at which we pour backfill underground. These are all the things that we have to do. And finally, for me, the most interesting part is the interaction of people and machines. We've tried for 30 years in our industry to come up with the highest level of automation we can with the hope that we would actually have a completely automated operation. What we need to have is the optimum level of technology that unites the capabilities of people underground and machines. It's not the highest level of technology, it's the optimum level of technology. Automated machines are very, very good at doing simple, repetitive tasks over and over and over again. But this environment underground is a highly variable environment. It's actually closer to farming than it is to manufacturing. Conditions are changing all the time, and they change very radically. And the only computer that is good enough to cope with those changing conditions is the human computer. We can use the machines to take the heavy physical work out of the process, but we don't want to remove the intelligence from the process. So we want to come up with the optimum level of technology, and that means improving the way people behave. This picture here shows the kind of clothing that we typically use at the present time. It's also the kind of clothing that we used 30 years ago when I started, and 20 years before that. Unfortunately, if we want to attract a whole new generation of people to our industry, it will be very difficult for us to do that because nobody wants to join an industry where you are dressed the same way your grandfather was when he was doing the same job. That's not an attractor to our industry. And it needs to change. It needs also to change because of the physical conditions that we have to cope with. Here we are, ultra deep conditions below 2.5 kilometers, probably in 50-degree centigrade temperatures. Not a tolerable physical environment.
How long is that?
Within 10 years, everybody working in these deep operations will look much more like a space astronaut than he does look like a miner. And this is 5 to 10 years, not because it will take us that long to develop the equipment, simply it will take us that long to have our mining companies adopt the technology. This technology is available now. I want to say that we have no interest whatsoever in taking mining into space. We don't think that's a good place for us to go, but we absolutely do want to bring in technology from the space industry into the mining industry, and that's what we propose to do, and have cooling suits that keep people cool, give them communication devices that look like this, noise-cancelling earphones. Those of you who flew to Toronto today or yesterday probably used noise-cancelling earphones so you could watch the movie. We want to use noise-cancelling earphones underground so that we don't have to shout at one another, which is our typical means of communication at the present time. We'll have suits to keep everyone cool, and it actually means that we can actually move expertise through the mine with voice and video without actually moving people through the mine. And that speeds up our operation and makes us more efficient. And if we're cut off from the airstream, we actually then avoid losing 4 to 6 hours at every shift change because of ventilation issues. Because the people will not be breathing the same air that is flowing through the mine site for the machines to use. So here we are in what you call Northern Ontario. In actual fact, Northern Ontario is there. That's the rest of the province. And you can see that big red circle, that's the Ring of Fire. That is roughly 400 kilometers from the nearest road. And that's the challenge that Richard's project faces. And we think we have some technologies that will actually improve that. These kinds of vehicles, hover barges, very slow, ponderous machines, but actually can carry huge tonnages, 200 to 300 tons of material being moved in on a daily basis into these locations. So CEMI's focus is to open up new deposits by finding new deposits and exploiting them quickly, increasing the productivity of existing mines, helping us to mine the deeper deposits more effectively, reduce our energy consumption, and to increase the value that we extract from the tailings dams that we have. Because many of those tailings were produced more than 50 years ago, and our processing techniques have improved significantly. There is significant value contained in those tailings dams that we can extract and redeposit the tails in a more benign fashion. That's our objective. So, that's all I have to say as a summary of what we're going to talk about. And I'm now going to hand it over to Dick DeStefano, who's going to talk about the service and supply sector in Northern Ontario. Yeah. Yes? Thank you.
I can't hear each other over here. I'm sorry, what's this for?
You don't need it.
I'm not going to need it. I have no PowerPoint, but I just want to fill you in some context of what we have done. Does anybody in here know who Michael Porter is? Oh, great. So I got some. Are you a disciple of Michael Porter? I am. I'm a disciple. 10 years ago, I had retired, and we were looking at how to create more wealth in our community with a series of workshops that we talked about, and we talked about diversification. And we kept saying, let's diversify, let's diversify. And it's interesting, after 25 years of consulting in the field and doing diversification studies for communities across the country and in the private sector and public, I came to the conclusion in my old age at that point, which is even older now, I came to the conclusion that we're diversifying communities into such thin banners that we're really not producing any wealth. I mean, we're going to spend $1 million on tourism and $1 million on a horse racetrack and $1 million on this, and we're going to, by the time it was all finished, there was no priorities. Then I started looking at some management techniques. I met Michael Porter, talked to him, and said, we've got a problem in Sudbury because I'm tired of hearing about black rock, moonscapes, strikes, cycles of poverty, low commodity prices, and everybody wants to give up. There's a despondency in our community. I need to find an alternative. And literally, I needed to find an alternative. And I spent the next 10 years, and I'm going to conclude. I'm going to keep this brief because I'm trying to just say that the people who are here talk about mining. I'm much more interested, not in mining per se, but in a structure that created a cluster that is recommended. And it was based on one quote. Michael Porter claims that clusters have the potential to affect competition in 3 ways: by increasing the productivity of the companies in the cluster, by driving innovation in the field, and by stimulating new business in the field. According to Porter, in a global economy, while there may be certain locations have specific endowments, now the competitive edge is not overcoming input costs, but how positive and productive you make the inputs in requiring continual innovation. And I think Doug showed you some of the innovation. We're particularly pleased with the fact that we're a value-added cluster. And you're going to hear the words with pride that we have gone from being a place where you go and watch the acid rain eat away the paint on your car to driving into our community with 335 lakes and all of the possible advantages. But what I did find out is that we had an invisible wealth creator in our community and in Northern Ontario. 100 years of mining in gold and cobalt, and you carry that down into Sudbury, into nickel. Nickel was king and gold are still king. But nickel was king for years. And I started to look at what was happening. I came to the conclusion personally, before I even called a meeting and tried to get people to support me on this cluster model, that there was value in banding together a particular wealth creation group called service companies. Everybody kind of looks at it and says, oh, yeah, okay, so what do they do? Well, while the mines are critical, exploration is even more critical, and then you can't produce success in a mine. If you look at the imagery that you just saw Doug put up, the imagery is showing you spacesuits underground. I mean, 8,000 and 10,000 feet is a little deep, a little warm, and somebody's got to come up with a technology or applications that solve the problem. We also started to look at how we could take this whole concept like they did in Seoul. Seoul created in 1999 something called the Digital Media City. 135 acres, allocated millions of dollars, created a critical mass, and they brought entertainment in, and now it employs thousands of people. What we found, and I'll finish off with some of this at this point, is that if I took the membership and was driven from the bottom up, and we had our companies stop being predators amongst each other and started to coordinate a marketing plan, a promotions plan, and I started to bring in international trade officers, 120, and we brought together 5 people for the first meeting. I thought, my God, I'm going to retire early, I'm going to play golf, I'll watch the Black Rock stay here forever, we're not going to change anything. And then 7 people joined. And like it's $1,000, like the guys were blowing that money on ads in a magazine that nobody ever read. And I said, give me some money to get started. FedNor jumped in and gave us $40,000 a year. In about 5 years or 7 years, we had close to 80, and we now have 130. You cannot believe what a cluster does in attracting international attention. We did a study with Doyle Tech in 2008, and it indicated something that I was making up to that point. If you're going to sell something, you don't always have to tell all of the truth. You have to tell there's some of the truth to what you're saying, and somebody can't criticize you for the statistics because you can prove that nobody else has those statistics. We did a study. We found 3 things. That our supply and service industry had 500 companies who spent 51% of their time supporting the mining industry. 506. We found in Sudbury there were 320 companies who were at least 40 to 50 years old who were supporting the industry. We found out from the study that there was close to 25,500 people working in the supply and service industry, which is triple the number of people in mining and extractive. What a human resource. What a power base. What an ability to generate. From that point on, it was starting to become an easy sell. All of a sudden, when you're a winner and people see you being a winner, you actually get acknowledged and you get invited to speak, which was rare. No one wanted to hear us at the beginning. None of the government agencies at first wouldn't support us. They said, they're all making money, let them handle it on their own. I can now claim, and according to the Canadian Chamber of Commerce, and I'll close with that because I'm going to be on time, I promise you. I can now claim the Canadian Chamber of Commerce did a study in the resource industry in Canada. They picked Vancouver for exploration worldwide in Asia as a top center. They picked Toronto, a Bay Street, for financial advice. And I can say with a great deal of pride, they picked Sudbury as a center for underground mining intelligence. We did it. I'm proud of it. We're great. We're all over the world. In the last 3 weeks, I've had a request from Poland, due to some of our members. I had a request from Hungary. We had a request from Germany. All of a sudden, we've been seen as the people who can solve a problem. And it's all because we branded internationally and got beyond ourselves. We're doing a hell of a job. Thanks.
Thank you, Dick. Very good. Thank you, Dick. Now I'm going to ask Dr. Dean Millar to come to the stage and talk to us about how to run mining operations with only 40% of the energy that they use at the present time. Over to you, Dean.
Thank you very much, Doug. I hope everyone can hear me. I'm going to show some slides now which indicate how you can reduce, for a very modern mine, the energy it consumes today to 40% of its current value. This is something that when I've explained it to other people, or stated the idea, they haven't believed me. So I'm taking the opportunity to actually show how it can be done. If you want a copy of the slides, use your phone to get a copy of the barcode and it will take you right there. Should just acknowledge my research group. Some of the ideas I'm going to talk about today are attributable to them. And the research group really wouldn't have happened at all without the support of some of the companies and other organizations which are shown on this slide. So on to the main business. I'm going to explain how this can be done with reference to a case study. The case study is Nickel Rim South mine. It's Sudbury's newest mine. And it's quite a challenge to try and get down to 40% of current consumption for this mine because Nickel Rim South actually already deploys a huge amount of innovative technology to lower its energy consumption. To give you a feel for the magnitude of energy that Nickel Rim South consumes, just to put it in context for those who are not familiar with the mining industry, it consumes roughly 6 times the amount of energy that a large general hospital consumes. So the picture here shows 6 Sudbury district hospitals, and Nickel Rim consumes about the same as 6 of those. So I am an academic, and so there will be some math to do here, 1 or 2 equations. This shows the details of the energy consumed at Nickel Rim South. This is public domain information, and if you want to do energy management for any industrial undertaking, and mine is no exception here, you need to know 3 things. You need to know how much energy, you need to know what form the energy is being consumed, and you need to know what the energy is being consumed for. So just to highlight one of these things, Doug mentioned ventilation as being very important for mines. For Nickel Rim, it is the largest demand center, 55,000 megawatt hours per year, about 32% of the total energy. And they also consume natural gas, diesel and gasoline, but about 80% of that is electricity. So what's the first thing to do is, to lower this energy bill is to switch to electric vehicles used in the subsurface. Pretty recently, diesel particulates were classified as carcinogens. I think it's only a matter of time before diesel equipment will be phased out of underground as a result of that. But it's actually not that new, but the challenge facing the mining companies is one that might be very similar to a challenge you're facing if you're thinking of buying a new car. You've got a choice here of buying a Chevy Volt, which is an electric vehicle, or let's say you could compare that with the Chevy Cruze, which looks very similar, about the same sort of size. You'd use this car for the same sort of thing. Just staying with the main message here, it's going to cost you $43,500 to buy, less $8,200 rebate for the Volt. And the Cruze is going to cost you $22,000, so quite a bit less. But then you look at the energy costs each year, and for the Volt, it's going to cost you $700 a year, whereas it's going to cost you $2,100 for the Cruze. So it'll take about 8 years to get equity between the two units. So this is very indicative of the sort of decision that faces mine planners on what sort of equipment they're going to use. And if they're got a bit of if they're starved of capital, then they'll go for the Cruze. But if they want to see the real benefits in the longer term, they'll go for the Volt. Now, the big benefit is actually nothing to do with the fact that electric powertrains are far more efficient than diesel powertrains. The big benefit is that you can lower the ventilation. And remember that 50-odd thousand megawatt hours I was saying about? You could cut that in half. And furthermore, the amount of energy that we're using to move things around underground is reduced appreciably as well because of the higher efficiency of the powertrain. So look at that, just one thing. Switching to electric vehicles brought us down to 71% of the 2011 consumption. So what's next? Well, Dick introduced us to one of his heroes, Mr. Porter. I'm going to introduce you to one of mine. This is a guy called Charles Havelock Taylor. He was from Ontario. He was a pioneer back in the early 1900s of this technology that I'm illustrating in this graphic on the left, called a hydraulic air compressor. It's got no moving parts. It compresses air very, very effectively by inducting water into a shaft. The water passes down, inducting air with water passing down this shaft. And as the water pressurizes, so the air bubbles get pressurized as well. So you get compressed air at the bottom in this separation chamber. And this serviced 29 odd mines in the city or town of Cobalt for about 70 years. It only stopped twice. It had no power input, no electric power input, just used natural hydropower from the Montreal River. I think we should resurrect this technology for Nickel Rim South and also do one other thing, which is to introduce crushing equipment, high efficiency crushing equipment, as it turns out, and high efficiency grinding equipment in the subsurface. So that we grind the ore down to a sort of flour type texture, add the free compressed air, and add the water, and then just lift the ore to surface. So that, if they did that in Nickel Rim South, would mean that they'd get rid of their energy costs associated with their second highest cost center on the energy bill. So that I'm calling an airlift. And then obviously also we get compressed air from this compressor too, and so we could shift both of those over into a renewable energy column. Look at that. Two measures. I've halved the amount of energy consumed and the bill for energy as well. What else would we do? Well, at Crichton Mine in Sudbury, they have this thing. It's about a 1 cubic kilometre pile of broken rock, which doesn't sound immediately useful on its own until you learn what they've been doing at this mine for a number of years. In the summertime, they draw the warm air across the broken rocks, and the warm air heats up the broken rocks and cools down the ventilation air, which helps the mine the miners and the equipment in the subsurface operate more effectively. And in the wintertime, the cold air goes across the same rocks, and that heat, which was stored in the summer, is used to heat up the winter air. With the result that they don't use any natural gas for heating or the air, or any refrigeration plant for cooling it at Crichton. And so we should do the same sort of thing at Nickel Rim South, but a more engineered structure. So if we did do something like that, and I've called it an isotope, that would allow us to remove one form of energy that we supply to this mine. We'd get rid of the natural gas requirement and move the heat ventilation air aspect over into the renewables column. So still not at 40%, so what do we do next? Well, we have to turn to more renewables, and the first one I would pick is photovoltaic technology, converting sunshine into electricity. These are some examples of, prior developments in floating photovoltaics, all of which are based on pontoon systems that float on bodies of water. At MIRARCO, we're doing research on what we call thin film flexible PV, which float on water bodies. And the big advantage of this is that the water cools down the PV panel while it's in operation and maintains its efficiency. So in operation, these PV panels will be far more efficient than those on a roof, for example. And what we've got in mind, this is a picture of Victor Mine in the far north of Ontario, the proper far north, Doug. This is a water treatment facility. What we'd propose to do is to put floating panels on that. That would give us about 3 megawatts of electrical power. And for Nickel Rim South, if we did this there, that would, we would use that power to deal with dispatchable electrical loads. These are bits of equipment that you can hold off until the power is available, because clearly the renewables is intermittent, and so it's not available the whole time. But we don't need to pump the water the whole time if you have enough surge capacity underground. And so we can shove more electrical consumption over into the renewables column, but still only 44%. So one more thing is required, and I'll turn to wind energy, as Divik diamond mine has in the Northwest Territories. They consume 50 million litres of diesel a year, and that costs them $70 million. They think they can reduce that diesel consumption by 10%, so that's about $7 million, and repay their capital investment in these wind turbines of $33 million, so that's about 4.5 years. So this is something that they've done. This is an operating scheme. And again, if we did the similar sort of thing at Nickel Rim South, which we can because the wind climate at Divik and the wind climate in Sudbury are not that dissimilar, we would then be able to charge those underground vehicles and other batch processes like the production of backfill at Nickel Rim. And there, eureka, 37%. We have reduced the energy consumption, primary carbon energy consumption, to below 40%, using just about 7 different measures. Some of them well established, others a century old, others clearly right at the lead edge of the innovation game. But what I hope I've shown is that there is this huge economic, financially beneficial synergy between the mining industry and the renewable energy sector, which we hope to see grow even further. There's a summary of the measures. The detail is in the small print here. So if you do want to see what the small print says, you'll have to download the slide deck. But let me tell you what it means. These measures that I've explained for Nickel Rim South wouldn't be the same as measures for a different mine. So what we're saying with this sort of 40% mine idea is that we need to examine a whole range, a whole portfolio of energy management, renewables technologies, and find out how they map to mine production facilities of particular types. So there is one old saying in mining that mining likes to be first to be second. This means that they're averse to picking up innovations immediately, and there's a good reason for that, and that is that there is enough business risk attached to the variability of ore body grades, enough business risk attached to mineral pricing to make the challenge of designing and bringing a mine into existence very, very difficult. So what can we do to try and make that an easier thing? Well, I've got these 4 ideas here. The first is de-risk through demonstration projects. I was very pleased to hear the Minister over lunch indicating that he thinks that's a good thing to do as well. I think we need to change mindsets as well. So there's some work on psychology associated with some of these energy-saving technologies that needs to be done. We need to bring on new business models, and that's research that we're undertaking at MIRARCO in Sudbury. And then, as a university professor, I think I need to work on my students to get them to understand some of these new technologies as well. So, last thing really to say is, it's another old saying of the mining industry, and I think it echoes one of Doug's comments earlier. If it can't be grown, it has to be mined. It means that a mining business, the mining business, underpins a whole part of a modern economy, and Ontario is no exception. So mining business is a mainstay of the province, and I urge you to continue to support mining innovation. Thanks very much.
Thank you, Dean. I'm quite sure that not everybody believes that you can reduce the energy to 40%, although I believe it. Anyway, we'll keep the questions till the end, and we'll move on to Daniel, who's going to talk about the reclamation of diamond wastes in the very sensitive environmental locations in the very far north. Daniel.
Thank you very much. Just waiting for the slides.
Press the button. Oh.
Is that what we're looking for?
Just go forward. Just keep pressing the green button. No.
It's the forward button?
The green button, yeah.
Okay.
There you go. Is that you?
Yeah. So back up here. So thanks very much, folks. So my goal today is to be perhaps a little bit more general than Dean has, but try and present to you some of the ideas, some of the needs for perhaps innovation in another way, and innovation in perhaps in the environmental field as well. So let's just talk what's called the mine cycle, or the mining cycle. This occurs in pretty well every mine. Usually start off with exploration of the mine, so it's 8 to 10 years. And think of, as we're going through this list of what you have to do as far as innovation and what kind of high technology fields you need. You need geologists, you need exploration physicists, geostatistics. So exploration is 8 to 10 years. So then you go on to the environmental assessment and approval stage, where you're actually doing more designing and evaluating whether your mine can go ahead. So you're bringing in engineers, environmental scientists. You're constructing the mine afterwards, and perhaps that's a little bit lower for a high qualified personnel point of view. Then you operate the mine for another 10 to 30 years, and then you close the mine. Okay, you close the mine, and then you start doing reclamation and monitoring. The point I wanted to make here is, so reclamation is at the end, and that's what I'm going to be talking about today. But it's actually, if you have to be able to do that well to be able to start the cycle again. Okay, because this is what we haven't done very well in the mining industry over the last, well, historically, is we haven't cleaned up after we finished very well. So you have to be able to get that last step right to be able to start the cycle again. So I wanted to talk a little bit about what I'm doing in the research, as sort of an example of that in the far north of Ontario. And this gives you a view of that here. So there's lots of information on this map here. Just look at this one. That's the Ottawa-Pascat River watershed. Just look at it and compare it to the size of southern Ontario. It's about the same size, big, huge. You have two colors on the map here. You have the Hudson Bay lowlands, the third largest wetland in the world. And then you have your shield beside that. You have a series of mines. You have the Victor Diamond Mine, you have the Musselwhite Gold Mine. Then you have the Ring of Fire sort of on the edge there, which is a large area that will be developed in the next coming years. Then you can see all these sort of stars around here, which are the population centers. They're all First Nations communities, and so relatively very, 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 very low population density. But these communities, they're all Cree or Ojibwe Cree or Ojibwe communities, and they have a very strong land ethic.
Good afternoon, ladies and gentlemen. I just want to remind all the exhibitors the show hours finish today at 5 o'clock.
Okay.
To stay
So,
in your booths until that time.
So,
We would appreciate your cooperation. Thank you.
thank you. Okay, so the point here is that if you want to be able to go through with mines in this region, you actually have to involve the local people, and you have to make sure that they are the center of your operation in many ways. And you actually have to then deal with some of the major concerns, which include environmental concerns as part of that. So here's just a shot of the Hudson Bay lowland to give you a feel for it. So it's huge wetland environment. So only about 2% of the landscape's upland, so you'll get your feet wet about 98 times out of 100. So permafrost underneath most of these peatlands. So very, very pristine environment. Just gives you a feel. This is Marissa Tallarico, who's about to cut down a small a black spruce here. And these are very, very slow-growing communities. So this is, for an instance, as we're looking at some dendrochronology on these trees, and you can feel for it. They have very, very slow growth. They're growing about 0.2 millimeters of ring width per year, so it takes 5 years to make a millimeter of radius of wood. So very, very slow growing conditions. And in the middle of this, they have the, in this case, the Victor Diamond Mine. So you have a very high reclamation standard that's required in part by the local communities to be able to, that they're asking for and they're demanding for. They're looking for native vegetation, local vegetation, and they're also wanting to ensure that after this mine's finished, this was perhaps an area where someone's grandfather trapped at one point. They want to make sure that at some point someone else's grandchild will be able to come back to that site and actually still be able to have the ecosystem services, will get food off the land, be able to make sure there's clean water, et cetera. So, and the other point here is that this is really isolated, so you actually have to use local materials to be able to reclaim the site and bring it back into that natural system. So, so what I'm trying to get involved with is working in developing reclamation protocols to be able to restore these sites afterwards. So this is, for instance, just a pipeline that they've put in. So this is peatland disturbance. So how can you actually try and rehabilitate this? So we've actually gone through a series of experiments to see whether you can get peatland to actually grow back. So, and if you want to aim for the peatlands to grow back, you have to aim for the peat mosses themselves. So this is, for instance, after a year, you get some of the peat mosses coming back to some degree. And within 3 years, you actually have about 80%, 70-80% bryophyte cover and 40% sphagnum cover, across a series of different types of treatments, which is actually really encouraging. So in other words, the technology or the techniques that we can put in place to restore these sites seem to be working and seem to be promising. We're working now on trying to look at winter roads and how they're rehabilitating, et cetera. When you're trying to look at reclaiming the upland sites here, it's a bit more of a challenge. This is an area which we don't have very much information on. We don't have the information, for instance, where we have information perhaps from Alberta and some areas and other similar environments where they have done some mining, where how to get some soils back, but it really has to be focused in Northern Ontario. So first, we've done a few things here. First thing we've done is we've looked at, well, if you're going to reclaim it to something, and if you have to try and figure out what you're going to reclaim it to. So this is a site, for instance, this is actually one of these rare upland sites. Oops. It's one of these rare uplands beside the Hudson's Bay lowland, where we went to look at the reference conditions that were there to actually see if we could try and determine what are the communities, what are the soils and vegetation like, to be able to try and bring similar soils and vegetation back on mine sites. And so you came up with this with a series of a wide variety of parameters where you can look at. So this is just pH and bioavailable phosphorus, but we looked at a series of reference sites from interior areas and other reference sites along the rivers. And the peat and the silty loam, the processed kimberlite are materials from the mine sites that they actually have to work with. So you can actually, at least with these two parameters, you can see what we're actually the silty loam material is not far from the reference site, and there's probably ways to try and mix these materials to actually come and get closer to something that would be able to be restored in this region. Here we have just the different types of materials that they have to work with to be able to restore the site. So we have processed kimberlites, limestone, silt loam, and peat in various quantities. Okay, so now we were working now in soil science of actually trying to see what's the best types of mixes to be able to make a soil that's functional, that's similar in some ways to the materials that we see or the soils that we see in the reference areas. And lastly, the third project I'm really, really briefly talking about is actually looking at the best upland natives plants. So if you're trying to restore these areas, one thing you may not know is actually most mine reclamation areas in Ontario still use non-native species largely to restore the mine sites. And so what we're trying to do is we're trying to come up with a set of species that are native and that would be able to use perhaps in a hydroseeding model or in different planting models to be able to restore mine sites. And we've just gone through a series of species to look at and be able to categorize them based on their ability to disperse, establish, produce biomass, persist, et cetera. So we can now plan a bit more how to restore these sites after they're done. Okay. So ongoing research that we're doing now, we're looking at field plots, trying to look at soil mixes and how they're at this larger scale. We're looking at studies of soil function and look at microbes and how they are actually reacting. How can we make a soil that actually reacts somewhat similarly to native soils up there? And we're also looking at other aspects such as nitrogen fixation, mycorrhizae, which is inclusion of fungi in the soil to actually create a functional soil, et cetera. So all these studies, what we're looking at, you can see, is that we're trying to aim for technology to really facilitate, perhaps facilitate the opening up of mines in this region. So how to get, if you can get that last step in that mining cycle right, okay, you may be able to open up mines more easily and to be able to proceed with economic development in the far north. So that's all I have to say. Thanks very much, folks.
Thank you. Okay, thank you, Dana. It's an absolute fact that Ontario, despite all the reputational issues that we think we have to deal with in mining, Ontario is a global leader in how to reclaim industrially impacted lands, whether it's in the very far north or in Sudbury or in further south. And when you consider the damage that's done by urban communities and the agriculture that surrounds them, it's far, far greater than any of the mining operations that we have anywhere in the far north. So I'm sure you'll have some questions for Daniel later. And hopefully, Richard's going to join us now and talk about his project, and hopefully none of us will be here when Richard's project has to be reclaimed, because we'll all be long dead. This is a very major project that's going to move forward. Richard, please come and tell us how this is all going to happen. Very large deposit, probably very similar in size to the Sudbury Basin itself. Huge project. Thank you, Dan.
Thank you, Doug. Cliffs Chromite is a really exciting project. It will change the face of the world ferrochrome industry, and it's going to be the foundation for a new ferroalloys business within Cliffs. I'm starting with a decidedly low-tech slide today to show you, give you a feel for how remote the area is and the fact that we've got a completely clean canvas to paint upon. There are no limits to ideas and innovation here. All right, since Cliffs is a New York Stock Exchange company, I need to note that this talk does contain forward-looking statements about the chromite project. And while we put an enormous amount of thought, analysis, and engineering into it, there's always risk and uncertainty about future events. So the Ring of Fire is Canada's newest polymetallic province. Unfortunately, it is located in the remote James Bay lowlands. There is no infrastructure whatsoever. We're located about 250 kilometers due north of the town of Nakina on the CN main line. There's no road to the area. We're over 500 kilometers northeast of Thunder Bay. Once we hit the rail line, we have a further 740 kilometers to go to reach our ferrochrome production facility in the greater Sudbury area. So looking at these challenges, what makes it all possible? Well, Cliffs Blackthor deposit is an absolutely world-class chromite resource. We've identified over 100 million tons open pit mineable high-grade ore to date, and it's open at depth. All of this is suitable for open pit mining. Blackthor is superior to any other stratiform deposit in the world in terms of grade, thickness, chrome-to-iron ratio, and reducibility. In comparison to South Africa is the world's largest producer, and they control about 75% of the world's chromite reserves. They're mining seams that are only 1 to 2 meter thick and in many places underground. Our mineable widths start at 50 meters and go up over 100 meters. This slide provides you a basic overview of our project. We're starting with a conventional open pit mine. We'll be using hydraulic shovels and 300-ton haul trucks. This truck shovel combination remains the industry's #1 load haul method thanks to its high degree of flexibility and productivity. We're going to be feeding something less than 4 million tons a year of ore grading about 30% chrome oxide to the concentrator. The concentrator flow sheet is very simple. There's no grinding required, which is critical for a project without access to grid power. We'll have 2 stages of crushing, followed by heavy media and separation and gravity separation. And we'll be producing 2 products, a coarse concentrate and a fines concentrate, both grading about 43% CR203. From there, we have a fully integrated transportation system, starting with a loadout at the mine, a new 340-kilometer all-weather road, and we're terminating at a new transload facility that we'll construct on the CN. We'll be using convoys of approximately 70-ton haul trucks that will be moving all of the product in containers, a very environmentally friendly approach. From the railhead, we'll be shipping about 1 million tons of the lump product directly to Asia, mainly for the Chinese market. The balance of the concentrate production will be going to our ferrochrome production facility. And we'll be using 2 rotary kilns to feed 4 65-megawatt DC enclosed submerged electric arc furnaces. And from that, we're going to produce about 560,000 tons per year of ferrochrome. Our product will grade about 57 to 58% chrome compared to the South African product that's 50 to 54% chrome. So if we're looking at some of the key challenges, first of all, this is an extremely complex project. You're looking at a $3 billion mega project that consists of 3 sub-projects, the whole mine and concentrator facility, the integrated transportation system, and then the furnace production facility. There's no infrastructure. All the site facilities, power, and transportation have to be developed from a zero base. We're dealing with difficult terrain. The project's located along the western margin of the James Bay lowlands. We're at the northern end of the boreal forest in the tundra transition zone. It's exceedingly difficult civil works, as you saw from the cover slide. Drainage is poor with prominent string bogs and muskeg. It's a severe climate. Winter roads will be required to stage equipment for development, and there's high risk due to the uncertainty of the amount of time you'll be able to use these roads, especially when you're dealing with north-south roads. The best you can expect is about 6 weeks of full use of one of these roads during the year. And finally, electric power consumption. Up to 30% of ferrochrome production costs can be electricity. And for our ferrochrome production facility is going to take about 320 megawatts of power. So we need accessible power and a very reliable, robust grid. So obviously, the proper application of innovative technology can make a huge difference in whether or not a project is developed. Remote mines take longer to construct and establish. They require significantly more capital and are inherently more risky. So innovative technology has the potential to address many of these challenges development, and they're going to increase your NPV and result in improved safety, productivity, and efficiency. The key is the ability to balance your technology risk against the expected rewards. This is absolutely critical to project success. Business, especially large business, is often viewed as resistant to change, risk adverse, have a big bean counter mentality. And while there are elements of truth to this characterization, where else can you have major capital budgets that are there every year, and senior management has a fiduciary responsibility to the shareholders to manage this capital to grow the business or return it to shareholders? Engineers can be somewhat cavalier about this. They fall in love with new technology, and they're really easy to risk other people's money. The key to corporate approval of new technology is develop a compelling business case, demonstrate a strong ROI, run multiple cases using tools like Monte Carlo analysis, and clearly identify the risk and mitigation options. When you're looking at a project of the level of risk we're dealing with, no one's going to touch bleeding edge technology. But if you're looking at adaptive technology or adjacent innovation like Doug was talking about, there's a lot of technology that we can pull from other industries that haven't been currently applied, but proven in these other industries, and also look at things as differences in scale. In particular, the rotary kilns we're pulling from other industry, and the size of our furnaces is definitely a scale up. You also want to look judiciously at transformative technology. This is the most difficult to adopt, but often has the greatest impact. There's been exponential improvements in simulation software over the last 3 years, especially 3D simulation. And we're looking at simulation to rapidly evaluate multiple operations and design scenarios, looking for substantial cost and time savings. So let's look at some of the key opportunities we have. First of all, for the overall project, I mentioned the simulation software, but we're going to be using remote operation centers, and in all cases, we're going to be looking at automating and using remote assistance and remote diagnostics wherever possible. If you're looking at the mine and concentrator specifically, we're going to make maximum use of modularization, pre-assembly or precast wherever possible. But we'll be looking at fully autonomous drills, automatic sampling and analysis, downhole sensors, alternative truck designs, and natural gas as an alternative to diesel fuel. For the integrated transportation system, we're going to have real-time satellite tracking and communication. The road trains are going to have RFID tags integrated with manufacturing execution systems. And at the furnace production facility, we're going to be taking 2 technologies, rotary kilns for preheating, and we're actually going to be making a different type of physical product, granulated ferrochrome, which is really quite novel to the ferrochrome industry. So the first step is logistics systems, how you're going to get this built. Well, the current logistics systems are woefully inadequate. You're looking at helicopters and float-based and ski-based planes, mainly people movers, not cargo movers. The future is really in hovercraft or hover barges and heavy lift airships. The third workshop on cargo airships is going to be held in July, and in northern climates, it's going to be held in July in Alaska. Airships are really sexy and interesting, but a 250-ton capacity airship like this is many years off and just prohibitively expensive. When you're looking at hover barges, they're being used right now in very remote areas in difficult conditions, from the Yukon to Suriname. And the proposal and the test program that Doug mentioned that CEMI is working on to get a demonstration hover barge in could have a huge impact. You'd have the ability to use these winter roads instead of 6 weeks, to use them all season long. In terms of some of the technologies that are going to really make a difference in the project, the rotary kiln for preheating is probably the biggest. Chrome industry uses all dryers for fine feed to their furnaces. This is mainly due because when these places were built, electricity was really cheap. And in South Africa, especially during the apartheid years, capital was really dear. Rotary kilns are commonly used in mining applications. You know, the ferro-nickel business, iron ore pelletizing, and limestone are good examples. There's a real fear about kilns in the ferrochrome business. Fines are perceived to be a real problem, that there are sintering issues, that you'll get kiln ringing, and there was a disastrous test case in South Africa where they tried to direct reduce fines, wound up losing the kiln and eventually freezing the furnace. However, if you use kilns for preheating at the correct maximum solids temperature and discharge temperature, it makes significant energy savings. We were able to eliminate one furnace for the same amount of production with hundreds of millions of dollars in NPV impact to the project just by replacing dryers with rotary kilns. By the way, in iron ore, we're running our rotary kilns at a much higher temperature than we would be here. Another interesting thing we're doing is producing a different type of product. Ferrochrome has traditionally just been cast ingots that were then mechanically crushed. This is not a very environmentally friendly or health and safety friendly way to approach things. Generates a lot of dust. In addition, as you can see in the lower left, there's a lot of fines. Those fines are either sold at a discount or not marketable. What we're looking at is a product called Grand Shot on the right. It generates no dust, and it's a uniform material that's really great for the melt shop. It melts very well in the stainless steel business. And what you're doing is the hot metal leaves the tundish at a controlled flow rate. It hits a refractory spray head where the stream disintegrates into droplets that are distributed evenly over the whole granulation tank surface. Then they sink and cool in a countercurrent flow. It's a really nifty process. I mentioned precast and pre-assembly modularization. This is really going to be critical. I think everybody's familiar with precast concrete on the left. But if you look at these types of modules, especially ones that could be put on a hover barge, they really help construction, and you can construct them in an area where you have the trained workforce and move them forward. We've broken our entire secondary crusher down into modules so that we could build it off-site and move it up there. And then in places where you have access to roads, like at the ferrochrome production facility, you have things like pipe racks and conveyor galleries that can be all pre-assembled and moved. And finally, I want to touch very briefly on mining simulation software. It's unfortunate we don't have a lot of time because I had a bunch of neat little 3D videos that showed the simulation and how you could debottleneck your operation. But basically, you know, it provides you the ability, the capability to model complex real-world systems and analyze their behavior. And the benefits are really manifold. You're looking at the ability to test system changes without capital investment. You can use a simulation to predict performance for integrated systems. You're going to validate your designs and compare alternatives. You can do a lot of what-if analysis. It's wonderful from the theory of constraints. You can identify and resolve bottlenecks at all your mobile equipment and everything through the process and as you're through the transportation corridor. In our particular case, a tremendous value is going to be its use as a communications tool, especially for stakeholders like the First Nations who are not familiar with the mining and have a very visual culture. The 3D visualizations give them a real feel for what this project is actually going to look like. And finally, the risks are just like that with any model. Models only simulate or approximate reality or the real world, and it's the experience you put into and the time and effort you put into to really develop an accurate model. So that's kind of an overview of the project that gives you a feel for it, and I think we can go on to the forum and take your questions. Thank you.
Okay, thank you, Richard. So we've all had more than enough to say, so I'm hoping now that some of you will have some questions. There's a microphone at the back if you'd like to go to that and ask the panel anything you'd like to ask. I hope we've given you the impression that it's actually a very challenging industry to be in and one that's going to require a very large number of new people joining us to make it all work. Ross?
This is a question for Dr. Millar. Lots of terrific innovations that you're proposing. What do you anticipate either the challenges to be and or the steps to take to get a mine to start adopting some of those innovations that you're proposing?
Thank you very much for your question. I think touched on this, I think, during my talk. I think the first step is we need to invest in some demonstration technologies to overcome this first to be second type problem, which is a very real and legitimate reason why there's a challenge there. The other thing I mentioned was that I think there's some education work to be done, both in my sector, in the education sector, but also within industry as well, to elevate the importance of energy-saving technologies to mining businesses. In Sudbury, depending on who you speak to, you may hear some mining professionals refer to energy being their largest cost centre for their production operation. That's over labour. That's not the case for all operations. But that piece on education really should aim to bring everybody together and act in the same way towards energy saving and energy efficiency technologies. So there's two things.
Maybe to sort of build on that, the air entrainment down with the water system, you stated that that was used by many mines many years ago, had ceased to be used recently. So does it really need to be demonstrated? And if it was working before, I'm just trying to understand what either the mentality of the CEOs of these mining companies, are they just, this isn't modern and therefore let's not do it, or they think that's old technology and therefore the new one is presumably better? What needs to happen to encourage actual implementation?
Well, I think in that case, it is Taylor's hydraulic air compressor is a technology that has been unfortunately forgotten. The reasons why it as a technology went into a demise are fairly well known. 100 years ago, when it came to exploiting hydropower resources in Ontario and in other places around the world, electricity is a far more marketable form of energy to sell to a wide variety of suppliers than compressed air. So that was one reason. There were some technical issues. The gases can dissolve in the air when they become the gases dissolve in the water when the water becomes pressurized, so there's a bit of a loss. And what that meant practically for the miners in cobalt is that they felt starved of oxygen, because the compressed air actually formed quite a significant part of the ventilation budget for the mines in those days. And the miners could tell that hydraulically compressed air was being used because their carbide lamps wouldn't burn quite as brightly as when the oxygen was, or the air was mechanically compressed. So the technology got a bit of bad PR from the mining industry at that time. So, you know, these days, compressed air forms a negligible part of a ventilation budget, so that really isn't a legitimate reason. And then the other issue about, you know, marketability of that as a renewable energy resource, there are still niche opportunities for that technology. I stay awake at night thinking about what the opportunities for it are in a modern context. And so redemonstration, rather than demonstration, a re-demonstration of that particular technology, I think, is needed for similar reasons as we need to do demonstration projects in the end. It's a convincer. And I hope that Richard will be convinced, because I'm sure his ferrochrome facility will need an oxygen plant.
Anybody else with any other questions?
You're a mining company. Can you comment on adoption of innovative ideas from Cliff's perspective? And is it exactly what Dean is saying in terms of show us and give us the business case and then we'll buy in? Or is there a possibility of Cliff's, you know, taking some risk themselves in investing and trying this? Not necessarily this technology, but technologies and innovations in general.
Yeah, I mean, you know, I can't speak for every company, but we've always retained our own research lab where everybody, most of the big companies got rid of them. We still do applied research. We still have an automation and innovation group. So we're keenly interested in technology. You know, technology is what's going to differentiate you from the herd. We don't have the best money and we don't have the best ore bodies, so we've got to do them the best and get the maximum use out of them. So we're keenly interested in any technological edge that's out there, and depending upon what it is, you know, what the business case is, to determine how we would invest and how much of a leader we take in it. But if we see direct application to our field, yeah, we'll jump right in. I mean, that's why Doug and I are talking right now about the hover barges.
Yeah, please go ahead.
If these hover barges don't work out, what about rail instead of road? If the road lasts only a short period of time, it would seem that more fixed infrastructure would be good for your mine, but other potential mines in the area.
Well, okay.
So the question was, just to repeat the question, that's why it's helpful to go to the microphone so everybody can hear the question. The question is, if the hover barges don't work out, what is the challenges behind using rail as opposed to road? The road has, well, all the technologies have their own limitations.
Okay.
So,
well, first of all, a rail requires, you have to be north of 10 million tons before a rail even makes sense. We'd all love to have a rail. But anyway, you cut the economics of building a rail, you can never pay it off. I mean, the numbers that are shown for rail construction are unrealistically low. You're looking at 7 to 8 years to put a rail in. And the thing is, we're only shipping, you know, on the order of 2.3 million tons of concentrate down that line. All the next mines on the horizon are going to be copper, nickel, or PGE. You're talking about in the hundreds of thousands of tons. So at such point in time where you get the economies of scale and you can pay a railroad off, but I mean, you can't even make it work. You know, they talk about rail costs being rail being the lowest cost operating cost. And that's absolutely true if your capital is sunk like the CN. But we ran the numbers on rail, and you'd be looking at an operating cost of north of $100 a ton to pay off the rail. It's just not going to happen. The other thing is the road is actually quite stable. You can move a road around archaeological sites. A railroad, you can't. The railroad can't readily connect to the First Nations communities. The road gives you an opportunity for the government to splay off and reach these severely deprived and isolated communities. And the other thing is, I worked in Quebec and worked for the Iron Ore Company of Canada for a long time. There you have better conditions with that railroad, and there were a lot of derailments. Derailments are quite common. You know, spring and fall, you get breakup and freeze up every year. We don't want to be dumping ferrochrome concentrates into a pristine environment. So containerizing the material and shipping on trucks, definitely a higher operating cost up front, but in terms of the lower capital, it's the only economic situation. Now, if someone wants to build a railroad, we will be really happy to use it.
Anyone else want to challenge any one of the panel members? Dick, can you talk a little bit more about the kinds of advantages you've seen in surveys since you've developed the cluster? I think the approach that's been taken in the north isn't just applicable to the north. It has other applications to other communities in southern Ontario where this was largely driven internally, it wasn't driven by external forces. Yeah?
I'm not sure if you look around the world and look at how things are driven internally by an organization. And sometimes, I guess as I'm listening here, I'm awed by hovercrafts and your spacesuit underground and, some of the applications on how we clean up the mine sites. In years past, we didn't have the pressure, the companies didn't have the pressure that they have on them in the last 10 years on regulatory frameworks. So prior to that, we can solve some of the problems, but we don't need to solve all of them. And that whole concept of banding together in some kind of marketing piece, it's not a marketing piece, it's about shared beliefs. Mm-hmm. It's about saying, Dean has a problem or a solution, we can build a hovercraft, who can supply the metals for that particular application? So unless it comes from a shared belief amongst those people in the cluster, and I mean, I went to Silicon Valley and spent a week, and I came back, was overwhelmed with how many competitors were coming to rub elbows with each other. And because they believed that greed was good. Mm-hmm. I mean, that's what their motto was. Yeah. So the whole concept of structuring an organization that now is recognized worldwide is really a hard feat to achieve. And it's not just the one thing that happens, it's me partnering with you to know what you're doing and what Dean's doing. So when I get a call from Germany saying, do you have anybody who does underground electrical cars? I can say, yes, we got 5. They say, wow, what a superstar. It's like Walmart's of the North.
Okay, thank you. Yep, go ahead.
Thanks, Doug. Question for you again, Dick. Sort of the flip side of the question of what clusters can do. You've had this unique experience in Sudbury with SAMHSA now, and you're really quite justifiably looked to as sort of the dean of clusters in Canadian mining. What misconceptions or what assumptions when you went into this experience, this SAMHSA experience, have turned out to be more difficult to realize than you thought were going to be? I mean, we talk about the success, but let's learn a little bit from some of those roads that didn't work out as well as you might have thought as well.
Yeah, thank you very much for that question. I don't want to answer it. I take the Fifth Amendment. I try to be very careful about not talking in public forums about what went wrong, because people remember the part that went wrong and not the part that went right.
Let me rephrase then, Dick. Rather than ask you what went wrong, Based on your experience and learning with the cluster, what advice would you have for someone who was looking at starting a cluster?
It's taking predators' mindsets who are basing their market share on beating a competitor and making them understand that somebody else who has an alternative source of services is a benefit to you. I can do this, and by the way, do you know that CEMI's doing this research, and do you know that we got somebody on ventilation on demand? That's, if anything's been difficult, it's sharing the belief amongst those who are not even competitors. The second thing is, everything that the supplier, when you're going to talk to a supplier and create value, and we've been doing that, you got to give them something that is a business opportunity. I mean, I've got people in our 130, I have 700 people on my mailing list who are all managers, and we don't even have mines involved. And I got to negotiate with the mines to do projects, and then they tell me that our problem is scale. You know, and that's true. I mean, you're going to go do something, you're going to build a railway line, you got to find somebody who's built railway lines, and we don't have anybody that builds them. You're going to build hovercrafts, and you need 25 of them, scale. There's nobody in Canada. You'd have to go to Bombardier, you'd have to make a contract out. So the biggest problem I have that's stopping Sudbury from becoming a truly global force is scale. People don't have enough production facilities and so on. It's not markets. It's not even money. We got 5 banks sitting at our doorstep, not venture capitalists who give us money. But it's, and I don't want to sound redundant, but if you keep saying that we're selling intelligence and not product, and you keep saying it long enough, the people who actually you're talking about, they begin to believe that they're intelligent. And then they begin to talk about how good they can solve a problem. And that's why when you get a guy like Vern Baker from Minnesota, Duluth Metals come in, and he says, I'm coming here to get everything. I'm coming here to get everything. He said, there isn't anything you guys can't solve. The problem we're worried about is, do you have the volume and the capacity to do it? And that's probably the one weakness that we have, because we've got competition, and it's not American, by the way. It's BC and other places. So I don't know if that answers your question.
No, that does. Thanks, Dick.
I'm not going to tell you anything more negative anyway.
Thank you.
Okay, very good. Thank you. If there's any other questions, we'd like to have them before we close down, and if not, I'll ask Ross to come back up and close out the session. Thank you.
Great. Thank you very much to the audience and to the panel and to Douglas for moderating. We're going to hand out a few tokens of our appreciation to the panel. And thank you very much for the audience for participating today. And please enjoy the rest of Discovery and a safe journey home. Thank you.